that when solving two-step equations, you are undoing the order of operations. Okay, what word do we use to remember the order of operations? Right, PEMDAS. You see it right here on the left. So that means that essentially when we're solving, we're going to go in the other direction. Okay, we are going to add and subtract first. Then we are going to think about multiplying and dividing. And then we are going to think about our parentheses, our exponents, and our parentheses and our exponents. Okay, so we're going to kind of do it in opposite order. Now, is this a hard, fast rule? No. Sometimes it might be in a different order, but in general, okay? To see a very simple example of it, some of you have probably done sum solving before. Can anybody explain to me how they would do A? Yes.
First step, you have to do minus 9 on each side.
Okay, so she says we're going to subtract 9 to both sides. Do you agree with her?
Yes.
Okay, so think about order of operations. When do we subtract? At the beginning of order of operations or at the end? At the end. But now, when we're solving, we're going to do that first. Okay? So when we do that, the reason why we want to do that is to get the 5x all by itself. And now what is 24? Okay, we got 15. And now what?
Divide by 5 each side.
Diana? Okay, so both of you agree divide by 5, divide by 5. 5 divided by 5 cancels out because it becomes a 1x. We just don't write the 1. Okay, it's invisible. And then x is equal to 3. Okay? All right, so I know the check seems like a little excessive, extra work, all that stuff. You don't have to put a lot into it. Okay? Do 5 times 3 plus 9 equals 24. What is 5 times 3?
15.
So just check, does 15 plus 9 equal 24? If you agree, you're done. Okay? If you want to take it a step further and say 24 equals 24, you're done. Okay? But don't just like throw in the 3 and put a check mark at the end and just, oh, I assume it's going to work out. No, the whole idea of the check is to show that it actually works. Okay? So try and actually do the math. All right? All right. So B, to give you an opportunity to see what you can do and to talk it out, try B on your own and discuss with the people around you. What are we getting for this one? So some people are getting 1.2, and some people are stopping, and this is why. You're subtracting 5, you're getting 6 equal to 5x, and I see some people stopping there and thinking like they did something wrong. But, and this is why I want you to use the idea of the fraction bar for dividing. Like some of you are doing like divide by 5 and divide by 5. Try not to do that. Instead, do the fraction bar. And the reason is, when we do it this way, divide by 5, our answer is this, 6/5. We're done. X equals 6/5. Okay? Now, if you want to take it a step further, I will take the 1.2. Now, those 1.2 people out there, were you able to get that without using a calculator?
Yes. Yes.
Okay, that's good. Because remember, that quiz is going to be non-calculator. So because it's non-calculator, 6/5. Now, some of you might ask, well, can I write that as 1 1/5? Yes, you can, but you don't have to take that step is what I'm saying, okay? So now, if I check this, and I do 5 times 6/5, what happens with the 5s? They cancel out. Anytime you're multiplying by 5 and dividing by 5, they cancel out, and I'm left with just 6. Now remember, I'm adding 5, and it's supposed to equal 11. So is 6 plus 5 equal to 11? Check. It works. Okay? How are we doing with that? Good? All right. So we're going to see on C then, one of the ones that you're worried about, it's got a fraction. Okay? It's not that big of a deal. You just have to remember that fraction means divide. What's the opposite of divide? Multiply. There you go. See, you can do it. Okay? So, Diana, what should we do first? Thank you, Diana. Diana, what should we do first? All right, so she says that we are going to add 7. Do you guys all agree with that?
Yes.
All right, so we're adding the 7, and then negative 1 plus 7 is? 6 is equal to z over 3. So my goal now is to get rid of that 3. If I am right now dividing by 3, the opposite is? Victor says multiply by 3. All right, if I multiply by 3 and divide by 3, the 3's cancel, and I'm left with just z. And now you just got to tell me what 3 times 6 is.
18.
I heard 12, 18, and 19. 18. All right, so how about 18? All right, in terms of our check, negative 1 is equal to 18 divided by 3 minus 7. What's 18 divided by 3?
6.
Is negative 1 equal to 6 minus 7?
Yeah.
Check. Done. Okay? I know this seems like a lot, but literally that took us 4 seconds to do. Okay? All right? All right, flip over to the back. All right. If I were to look at the very first one here, how does it differ from the ones on the front? What do you see that's different?
They have 2.
They have 2 X's. Do you see that there are 2 X's?
Yeah.
You see that there's 2 X's? All right. So anybody got an idea of what we should do if there are 2 X's? Oh, Crossy, yes.
We subtract 7x minus 4x.
And what is 7x minus 4x?
3x.
So he says the first step is to combine like terms and make it into 3x. Brian, what do you think? Do you agree with him?
Yes.
Yeah? Okay. All right. So that's step number 1. Since we're supposed to be able to get these done in 2 steps, what is step number 2? Divide by 3. And x should equal 7. All right. So now you just have to show that that works. Does anybody know what 7 times 7 is?
49.
49. Minus 4 times 7. 28. And does that equal 21? Is 49 minus 28 21?
Yes.
Check. It works. Okay? All right? So do B on your own. See what you come up with. So since we're split between half the class being 4 and half being negative 4, let's make sure that each step is done correctly. What is D minus 5D?
Negative 4D.
Because some of you are writing it down as positive 4D when it should be negative 4D. So think about our sign here that says when the signs are different, we subtract and keep the sign of the higher number. Okay? So now, when we go to divide, what do we divide by? Negative 4. Negative 4. Because there's a negative 4 in front, we have to divide by that negative 4.
just did like positive.
No, you always have to keep the sign with. Okay, and so now a negative divided by a negative gives us positive 4. Okay? All right. Okay?
I didn't know.
All right? All right. We're going to add one more. This will be our last one. Okay? And essentially, it's an example like we did yesterday, and you guys did well with it. We're going to do one more. Okay? All right, I want you to write 13 equal to 8 minus D. We're going to do this because of what kind of just happened with the last example. So write 13 equals 8 minus D.
This is a new problem.
This is a new problem.
Can we get an extra credit?
No, not on this one. Okay. All right. So this is still 2 steps. What's the first step going to be?
8 minus 13.
She says subtract 13. She says subtract 8.
Subtract 8. Subtract 8.
All right, you always want to subtract the number that's on the side of the variable. So we're going to subtract the 8. Okay? All right, what's 13 minus 8?
5.
What does that equal?
Negative D.
Do you agree with her?
No. Yeah.
What do you want to say? All right? am I allowed to leave my answer as negative D?
No.
All right, so we saw an example similar to this yesterday. What should we do?
Plus.
Nope,
Like,
cross it.
Divide by -1.
There's an invisible 1 here, so we're gonna divide by -1 and divide by -1, and then we're gonna write our answer as D is equal to 5 divided by -1 is -5. All right, so if I check, 13 is equal to 8 minus a -5. What happens when I got two negatives sitting side by side like this?
become a plus. Click.
Click, click. Is 13 equal to 8 plus 5?
Yeah.
Check. It worked. Okay? So I want you to be aware of the fact that if you have just a negative variable, you're going to have to divide by a negative. Okay?